Alright, I'm going to go right into this to try to get your attention. This is a light wave, and that is just in midair captured from a red pulse laser. This is that same light wave that has now become highly distorted as it approaches what is called a venturi accelerator, which is two metal pins, circular metal pins, and as the light enters at a certain distance between the pins, it is a spinning light, and it crashes into there and causes this chaotic atomization, and it turns the red light into a brilliant white glowy light, and as it is crushed and forced to accelerate, which it does, through this venturi, it comes back out, and on quantum stages it recombines itself into light fibers, and I will show you that in a second. This is an atomic reaction that is electronic, not nuclear, I don't believe. Light, as I'm going to claim, is electrons, and light causes this spinning effect to crush itself in a venturi the same way gas atomizes in the old carbureted engines, and turns into a violent, glowy, accelerated mass that begins to reform. And when it reforms, I'm going to show you the most important picture that's ever been taken in this in energy ever. All right, as it reforms, that accelerated high energy particle here you see crashed into a low energy normal light disk, and it emitted a mini light disk, which means that light itself can be divided, not just nuclear masses, light. Light, I'm going to show you as we proceed through this presentation, is a particle, and that I believe we have proven beyond a shadow of a doubt. If somebody can possibly fight against the evidence that I'm going to show you, then I'd love to hear that argument. So let's go right into it now. But this, I believe, is a portion of light, which means that light can be completely taken apart into little bitty pieces. And the other claim I will make is that all matter is positive and negative, and that all matter contains an excess negative charge. And that excess negative charge, in addition to both of them having a strong positive charge, creates a separation distance which we call a quantum state. And I will show you that and demonstrate it. Alright, these are some of the earlier videos I did about, you know, the dual slit experiment, particle duality, and all that business, and vortex theory. These go back a couple of years, and they're on a different channel that I have now. These were on my Mud Space Fossils channel. I mean, I only got 265 hits, you know. There's very few people were looking at any of this stuff. So, anyway, now it's Mud Fossil University, and that's on YouTube. But anyway, these explain, you know, light is dark energy until it hits matter, and I believe that's a fact, and I can't see anybody proving that's wrong. Wave particle duality is resolved with vortex theory, and I explained that too. And this is 2 years ago. That was a year ago. This was 2 years ago. Wave particle duality, vortex theory, peer review requested. Nobody wants to review it. So anyway, that's what I'm claiming, and now I claim that net negativity on every single particle that exists has a positive and a negative, including light, and every particle can be divided down to almost nothing, and I show that as well. And the net effect of a net negative universe is that every particle attracts and every particle repels, and that accounts for exactly what we see, including gravity. Alright, this is a video by Wayne Schmidt, and it's a toy, but and this goes back a couple of years, but he's showing that all magnets or magnet, let me put it this way. Magnets, he is showing, in a certain configuration have a positive and a negative. This will always maintain a distance because they are both net negative. And that is my claim, that all matter is net negative. And that accounts for everything that we see in physics. All particles are net negative. They have positive, which is very strong, but they have negative, which is also just as strong, but only a little stronger, so that the net negativeness keeps them pushed apart, but the positiveness attracts them. See, watch, he can't make that stay there. He's pushing it hard, and it bounces right back. And that is the nature, see it? Boom, boom, it shakes. That is the nature of electrons in their orbits. All right, now I'm going to stop this and try to explain it to you. This is a strong positive. It's trying to find everything in the universe negative to pull it towards itself, which are the nucleuses. Which means that it pulls electrons because they are negative. But the electrons are also positive. Electrons aren't just negative. So what happens is the negativeness of this pushes away the negativeness of the next electron that comes to fill the next orbit, but it pulls it in because it is also positive, and that's also positive. So you have a declining layer of attraction. The first layer is extremely attractive, which is your atomic gases, hydrogen. Extremely powerful because the attraction is so strong. And then as you get way, 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 way out here, the power of that stuff is less, even though you say, oh, it's nuclear. Well, then you're into a whole different situation, because nuclear means that the internal mass of the nucleus is unstable. All right? That's what happens in a nuclear problem, where the mass splits, and it gives off a tremendous amount of energy. So we're dealing with electronic energy, and everything that I will show you relates to electronic energy. But the takeaway is that everything's positive and negative, and that accounts for everything. That's gravity, because everything that's positive and negative together, all the mass of the Earth is this configuration, but it continues to grow this positive, 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 bigger and bigger and bigger, and attracting the negatives harder and harder and harder. And that's why gravity keeps getting stronger and stronger and stronger, because the positiveness keeps growing. Even though there's still negativeness, the positiveness still attracts, and light is the speed of the negativeness that's here, of the positiveness that exists in the planet. So the light hitting things isn't necessarily coming in at full speed in my mind. It could be coming in a little slower, and it's accelerated by the mass that it's attracting it, which is the positive that's attracting the tiny little negativeness. And there's other people that are sure they're going to figure out this much easier and better than I did. But I'm just sort of giving you an idea of how I think things are working, and go from there. All right, this little picture I drew to show you how the sun shoots off particles, and it has to be this. This is so chaotic that it's sending out little particles, and they spin away, as I will show you shortly, and they spin away into the vacuum of space where there is nothing for them to collide with, so they become dark. They are matter because they are a particle, and in the space they become the dark particle and a dark energy, because they still have that energy, as we see, because it becomes manifest as soon as it bumps into anything that has mass to it, including a space station or the Earth, or any of the molecules that exist in the orbit of the Earth. That's just a fact. And Einstein said there was nothing between the sun and the Earth. It's insanity. Obviously, it's the same thing that left the sun as it is when it hits the Earth, and it is a particle. And I will explain this thoroughly. And I have the most important picture that's ever been taken in the history of science that you will see. All right, these are shots, actual photos taken in midair by a fella in Australia, Rodney Warren, And he was doing some other research about dimensions, and was sending me all of these photos, and absolutely phenomenal. So this is a single disc, unobstructed, just going across from a red laser. Now, what happens is he did something absolutely extraordinary. He was trying to do doing a slit experiment and a double slit experiment, those type of things. And unknowing to him, he grabbed a couple of nails and drove them in a piece of wood and held it up to the laser, and this happened. He could see this. The nails were here, round metal drums, pins stuck in here. The disc came along similar to what you just saw before, just a nice happy little disc come along, and all of a sudden it hit those circular pins, and because they actually drive the spinning particles in here, it creates a venturi. And that venturi has absolutely nothing that it can happen except to crush whatever enters that orifice, and it does violently. And this is the violent crushing, and you could see it's radiating out, glowing, very, very high glowy frequency. It almost looks like electronic Cherenkov radiation, which they use to slow down nuclear particles and radio, the nuclear reactors. The particles end up hitting the water, and they just glow like this, really glowy. And this is not a normal glow of a white, in my opinion. I could be totally wrong. But I think this is an excessive glowy white, and the electrons in here are in chaos, and I'll show you the chaotic electrons. Alright, this right down here, that's where the accelerator is. It's right in this area. This is highly magnified, obviously. Now, you can see them coming out, and all this glowy white turn into orange and then into red, and then what happens is they end up spinning back off in their normal orientation, which they spin. And I'll show you some pictures of that. Well, you saw the first picture, how it had sort of a nice little wave going forward. Well, coming out of here, they're just going crazy, but then they reform. And they reform because they're particles. And we see those particles. And those particles look exactly like the particles I will show you later in this presentation that were done by some people using hypertoroidal magnets, something along that. It's a big word, magnetism. I'll show you. The key is with that, the magnetism shots that I will show you, what it is it creates a torus. And the neck of the torus is the key to this whole thing that keeps energy bouncing back and forth in a spinning disk somehow. And we've seen it. I can't explain it. But that's why I'm showing this, because it has to be explained. Somebody's going to be able to figure this out. I'm not the brightest guy on the planet. So somebody is going to see this and say, "Whoa, wow." And they are the ones that are going to figure this out. So I'm just bringing this forward. All right, stick with me on this one. You saw those waves that came across in that original one. They spin, and they're waves. Now this is, each one of these, I'm almost 100% sure is a wave. Over here, if you can see over here, you see how there's a chaotic white blurry looking blob here? That is where the accelerator is. It's a little past over this direction, but this is as they start to reform, and they do. And they do it in two waves, like strobe discs. You ever see a stagecoach going, the old westerns? Hop along Cassidy or something. They're going down, and the stagecoach goes, and all of a sudden the wheels go backwards, and in the middle it stops for one or two waves. Exactly, it's the same thing. This is a stagecoach, and all of a sudden it stops, and then the guy goes back, and the stagecoach goes back the other way. See it? And in the middle it does this same thing. It's crazy, but it's what it is. Now you see how those things are I don't know if you were ever around when I was around, where they told you to duck and hide under because of nuclear warfare, which was coming next week probably. Those look identical to the things that they said were atoms. And you see them in these magnetic experiments too. It's very, very bizarre. And I don't, again, this is not me. Rodney did these shots. I just saw them and I sort of figured out what they are. So I didn't make all this stuff up, and I don't have all the answers. So somebody's going to have to look at it, but that's what I'm hoping somebody will look at. See, there's the same thing again. Two waves. Whoops. You see it? Two waves. Blip, blip. And those are, they're just, they look identical to those little atomic electrons. See it? There it is right there. Now, what I'm saying is this is a torus. And what happens is a torus, I'm going to show you a picture of a torus in a minute, but remember these things. You see these, the white boom, 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 the black boom, 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 boom. You see the spike coming out, spike coming out. Just remember those little attributes. All right, this is going to be a little hard for you to understand if you don't have a deep electronics background, but it's really not all that hard. This is a torus. Most people know about those. And this down right straight through here is the neck of the torus. Now this is showing that the thing continuously goes like in one direction and never stops, but that is not how an electron works. An electron works pulsating, boom, 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 boom. So it fills up this volume. When it hits the neck, it compresses it so hard that it creates what's called a reverse EMF, a reverse electromagnetic force. And that pushes the incoming backwards. And not only does it push it backwards 10 times the applied forward voltage. So if it was, let's say, I'm just going to use things which I worked with solenoids, and I can tell you a funny story about how I can prove this. At 10 volts, 12 volts, you don't feel anything in your hands. If you hold two things in your hands with 12 volts, nothing happens. But 120 volts, you're going to feel it. Now, what happened was, if you come into here with 12 volts, it will kick back at 120 volts. In this particular arrangement, it has a huge field of capacitance that can absorb that capacity. So it absorbs, and then it goes back this way, and now it gets popped in again. It says, oh, whoa, 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 whoa. Too much coming through here. I'm going to oppose you, and it kicks it back 10 times into the capacity again. And it sort of flops back and forth, and you end up with, you have to look at it from a different direction. You end up with two opposing fields of, and then your spikes shoot out the center, because that's where it's collapsing, and it's going to shoot out that little spin. So it's going broop, 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 broop. So you got a dark and a light, and a dark and a light, and a dark and a light, and that's what's happening. It's collapsing its field into this volume, which is what they call capacitance, and the term is called capacitive reactance. So it says, whoop, and it says, hey, oh, I got plenty of room for you guys. Come on in here. All right, slow down, take it easy. So they come in here and they sort of all collect around, and then it was shot into this one here, trying to be pulled through, and it can't pull itself through, and it forces itself back somehow. Now I'm sort of guessing at some of this stuff, but it somehow pushes itself back, being forced to collapse here 10 times. It says, push that thing back out of here 10 times. It pushes it back. It says, all right, we still got a lot of room over here. Come on back over here. So, and then it tries to get back over this way, and it says, get out of here. It goes back the other way. That's the way it works. Somehow it's working in that way. And somehow that creates some kind of linear spin. That's all I can tell you. And that guy talked about trumpets. I'm going to show you something what he talked about trumpets. But anyway, what you have here is, it's called capacitive reactance where it feeds into this big hole, and then this is called inductive reactance where it collapses that field that's coming in, this big field that's a round circle like I showed you with that big spring, and it collapses it and crushes it and forces it back the other direction. And I can prove to you this is true because one day I was trying to energize a solenoid, and I told my wife, I says, hold on to these two wires. And she said, I'm not going to get a shock, am I? I said, oh, no, it's only 12 volts. So it was a solenoid that drove a plunger. And when a solenoid activates, it fills up and it saturates the field. And at that saturation point, when you take away the current, it does the same thing. It collapses 10 times the applied voltage. So she's holding the thing, and I says, oh, don't worry, it won't hurt you. So she's holding it, and the plunger goes in, everything's fine. I pull the electricity, and she gets hit with 120 volts. and I just, anyway, that's the proof. And it wasn't really, anyway, it worked out somehow. All right, you see this? These are these are electrons, and they're spinning in a trail like this. And when he takes that picture, poof, it gets like a whole row of them all at one time. So that's all the same particle, and you can really see some kind of a strobe taking effect. Now this is the venturi, and you can see there's different colors of light coming out of here from a pulsed red laser. They should be all red, and they should all be the same frequency, the same density, the same intensity, and what it is literally the same impact. What I mean by impact is literally impact. So every particle that comes off of an electron, or every electron, I'm going to make this statement, I don't know if it's 100% sure, but I'm going to say every electron weighs the same amount. 0.00055 they claim atomic mass units. Alright, so they all start out and they're sitting on a counter weighing that. But if one of them spins out of here, and then let's say, well, first of all, they all weigh the same thing sitting on a counter. Alright, so let's get past that. So a particle at rest they all weigh the same, the electrons. So once we start pushing them out of here, spinning them off of the sun, if Einstein was right and they all go the same speed, which I totally disagree with, but let's assume that that's correct, and they all go the same speed, now they all weigh the same amount, and that's, let's say, 10 times that. Or let's say it's 100, now they weigh 0.55 atomic mass units, because they're spinning off the sun. So now when they hit something, they're going to whack it 1,000 times harder, let's say. Now, that's just going in a straight line. So now we got to take into account the spin, which is called the angular momentum. So the thing's going zzz, spinning, and it's going forward. So now, not only is it hitting you coming forward, it's hitting you like a bucket of water spinning around in a circle. All right? And if that bucket of water is spinning slowly, it doesn't really cause you all that much damage. But if that bucket of water is spinning at a zillion times a second, and it's going forward at the same speed as everybody else, but that one there has got some power to it, you're going to get hurt. And I'm going to show you one of those right now. All right, once again, these are same particle. This is a single particle. It's going out of here. And it's spinning like crazy, and we caught it, Rodney did, he caught it on the strobe. You see, there's the wagon wheel strobe. But you see what it's doing? It's snaking off to the left. It's drifting. Well, why would that be? Because it's spinning to the right. All right? It spins and it spins and it spins, and that means that the particle is drifting to the left. You see the compression at the end here on all of these? They're all single tube. Every one of these is a different electron. And they're coming out of the accelerator from the bottom, highly accelerated down here. And as they come out, this one here is more accelerated than the others. And they are going to be different accelerations because it's different entrance into that atomization venturi. So some of them will come in and become extremely excited, as this guy is. Some will be a little less. Some of them will come through, maybe straight through the center and hardly get hit at all. You see, this one's kind of a little shorty. I don't know what's going on with that guy. It's just, it's kind of coming out chaotically. So, but the key to it is every single one of them collapses as they slow down, hitting the new atmosphere. And out of that restricted zone, which can do nothing other than to collapse, crush, and accelerate. And when it does, Rodney says that it actually literally sizzles at that acceleration point, audibly. That's what he said. Now, one more time, just to show you, there's the normal pattern of a wave that's not accelerated whatsoever, just pushing along through the air. This, you can obviously see, is being sucked into that venturi right there. This is the atomization, and there is the quantum slowing down as they enter this new space. So they're entering through that slot, which is a venturi, and coming out and slowing and slowing and slowing. And I showed you the other thing. Now I'm going to show you the most important picture that's ever been taken as far as light or energy or any of that stuff goes. Alright, I'm going to make this statement. This is the most important picture that's ever been taken in history as far as light or energy or anything to do with atomic research goes. I showed you acceleration. You see this particle here? And that particle there? Those are accelerated light particles, which I showed you. And you see this here? You see what happened? You see this disk all of a sudden appearing? This is a chaotic particle disk, which struck a non-accelerated disk. This one's highly accelerated, highly energetic, and when it impacted this other light particle, now these are light particles, these aren't atomic particles. When it impacted this light particle, it apparently hit the same particle, but this one here, and this caromed off, and that is the trumpet this guy is talking about. This is what, these are the little spinning disks of light. Now, not only do you see that, you say, ooh, that's interesting. Well, it's a little more than interesting because it's telling me, and I could be wrong, but it's telling me that this highly excited light particle, which they claim they don't even think they don't even take them into account because they're 1,800 times smaller than every nuclear particle. So they don't think, these are smaller than quarks and everything else, you know. This is the smallest particle there is, they say. Now, that particle hit this particle and drove a mini particle off. Alright, so let's stop and think about what that means. That means that that particular light has either an excessive amount of energy, which it did, because it came out of the accelerator highly energized. So it's spinning or doing something more than it would normally do in the normal atmosphere. And it was able to give that excess light off as a mini light. All right, that opens a lot of doors here. This is so you can see this disk is huge. You see this disk? It's about 10,000 times smaller. Now, what does that mean? It means a lot, and I'll go into that in a minute.